Okay, this is for Algebra 2, and this is a review for rationals. Number 1, you're simplifying, so you're going to have to look at the top and find the factors of 6, 1 and 6, 2 and 3. Use your sign rules that are on the wall. They're going to be the same, and they're both going to be positive. And then you need to equal 5. So I use 2 and 3. So since there's not anything in front of x squared, I can just go to my parentheses, and I have x plus 2. And x plus 3. For the bottom, we're going to find the factors of 8. 1 and 8, 2 and 4. Signs are the same, they're all positive, they have to equal 6. So it becomes x plus 2 and x plus 4. You look for things that will cancel. Your x plus 2's will cancel. You cannot cancel these other x's because they are protected by the parentheses. So your answer is x plus 3 over x plus 4. Looking at number 2, it is a division problem. We're going to have to do leave, change, flip. So we leave the first one, 2x over. Notice that you can pull out a 3, and it leaves you x minus 2. Change to multiplication, and you're going to flip the second one. As I bring the x squared plus 5x to the bottom, I notice that I can pull an x out. So it leaves me x times x plus 5. The x minus 2 goes to the top. See what you can cancel? The x minus 2 cancels. Since it's on the outside, this x can cancel with this x. So that leaves me 2 on the top and 3 and x plus 5 on the bottom. So this is my answer. Okay, we're subtracting here, so I've got to find a common denominator. I have an x and a 5x, so my common denominator is 5x. I'm going to compare, and the first one is missing a 5, and the second one has everything, so I just put a 1. I'm going to distribute the 5 times the x plus 2, and I get 5x plus 10. Be careful, it is subtraction, so it's going to be minus 1. Combine your like terms, and it becomes 5x plus 9 over 5x. The 5x's will not cancel because the top one should be protected by parentheses due to the plus. So that's your answer. We're multiplying, so basically we're just going to factor and then cancel. So x minus 5 stays like it is. 10x minus 2, I can pull out a 2, and it leaves me 5x minus 1 times 25x squared minus 1 is the difference of squares. So I take the square roots, which are 5x and 1, and have 5x plus 1, and 5x minus 1. On the bottom, I'm going to come over and find the factors of 25, 1 and 25, 5 and 5. Signs are the same, they're all negative, and they have to equal to negative 10. So on the bottom, we have x minus 5 and x minus 5. Ready to cancel? X minus 5. Now it only cancels with one of the x minus 5's on the bottom, and then 5x minus 1. So my answer is 5x plus 1 over 2 times x minus 5. Looking at number 5, we're solving, so we have to find our restrictions. First thing you want to do is this x squared minus 4 needs to break down to x minus 2 and x plus 2. So your restrictions are anything that x cannot be, anything that would cause you to have a 0 in the bottom. So x cannot be 2 or negative 2. The way you get that is you take your denominator, like x minus 2, and say, okay, that can't equal 0. Move my 2, and so x can't be 2. You would say x plus 2 can't be 0. Move my 2, x can't be negative 2. That's where it came from. Common denominator is going to be x minus 2 and x plus 2. Okay, so now you compare. First one is missing the x plus 2. The middle one is not missing anything. And the last one is missing x minus 2. So set up your equation, and you're going to have x plus 2 times 3 minus 1 times 2x equals x minus 2 times 5. Put all of this at y1, put this at y2, Go to second, calc 5, enter, enter, enter to get your solution. And your answer is x equals 4. Same thing, start with your restrictions. X cannot be 1 or 0. The way I got that was x minus 1 equals 0 or not equal to 0. Move my 1 and x is not equal to 0. It's already by itself. I took each part of the denominator. So now we're going to find the common denominator, which is x minus 1 and x. Compare. First one's missing the x. The next one is missing x minus 1. The last one, think about it as being over 1, so it's missing everything, x and x minus 1. So make your equation, and it's x times 12 minus x minus 1 times 8 equals 2 times x minus 1. This goes to y1, this goes to y2. When you go second, calc 5, enter, 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 you get x is equal to negative 1. But you notice that it's a parabola and a straight line, so you should have two solutions, so do it all again. Second, calc 5, go way, 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 way to the right. Go a long, long, long ways. Then go enter, 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 and the other answer is x equal 4. Another thing you could have done was gone to zoom 0 for fit, and it would probably show you both intersections. Another of the same, your restrictions are x cannot equal 0 and x cannot equal negative 2. Your common denominator is x and x plus 2. 8 needs to be put over 1, so when we compare, you're missing x and x plus 2 for the first one. You're missing x plus 2 for the second one, and you're missing x for the last one. So when you write your equation, it's going to be 8 times x plus 2 minus 4 times x plus 2 equals x times 8x minus 8. So then we're going to put that in at y equal. So you have 8x open, x plus 2 close, minus 4 open, x plus 2 close. Go to y2, you have x open, 8x plus 8. No, that's minus 8. Close. Second, calc 5. Enter, enter, enter. X is equal to 0.4. I'm going to go with the zoom 0 just to see if it looks like they're going to cross twice. And they're not, so you're just going to have one solution. Okay, Fred pours a cup of hot coffee, but then he forgets about it and he leaves it sitting on the counter. As time goes by, the coffee cools off. An equation to model this drop in temperature is y equal 80x plus 300 over x plus 2. Here, x equals the number of minutes since Fred poured the coffee, and y equals the temperature of the coffee in the cup. About how hot was the coffee 1 minute after it was poured? Well, you want to start by putting your equation in at y1. You need to be sure and put parentheses around the top and around the bottom. So go to y equal and clear everything out. Go to y1 and we open 80x plus 300 close divided by open x plus 2 close. Now we want to know how hot it was 1 minute. Well, what you've got to do is say that x is 1. So go to your table, second graph, and go to where x is 1, and the answer is 126.67 degrees. Number 9, it doesn't show up on your review, but you still need to know how to do it. What would be the approximate temperature of the coffee 2 hours after it is poured? Well, 2 hours is still talking about x, except that x is in minutes, and 2 hours would be 120 minutes. So you're going to look at your table where x is 120. You can either scroll way down, or you can do second table set and tell it to start at 120, go back to your table, and you will discover that it was 81.148 degrees. You could tell me 81 because it said approximate. The last question, number 10, tells you to set up and solve an equation to determine how many minutes it would take for the coffee in the cup to reach a temperature of 85. In other words, when will y equal 85? So go put 85 at y2 on your calculator and find where they cross. So go to y2, type 85, second, calc 5, let it draw, enter, 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 and I'm getting an error. So what I might want to do is just go to my table and figure out when they're both 85. And I'm just using my arrow and just looking at them. This is the long way of getting there, but it will work. I'm still waiting. I'm at like 70 and it's not where it needs to be yet, but I'm headed in the right direction. See, it's taking a long time, but I'm getting close because, oh, there it was. At 26 minutes, they are both 85. So, 26 minutes. Okay, another thing you need to be able to do is if you're given something like this, you have to simplify it. Factors of 6, 1 and 6, 2 and 3. So it's x plus 2, x plus 3, over, pull out a 4 and an x, leaves you x plus 2. Your x plus 2's cancel. So you're left with x plus 3 over 4x, I'm sorry. X plus 3 over 4x. Vertical asymptote, the way you get that is you say 4x is equal to 0. You will divide by 4. X equals 0 is your vertical asymptote. Don't worry about that next part. If the x in a rational graph is replaced with x minus 2, how will the graph change? We haven't talked about it during rationals, but we've talked about it over and over, that it's the same no matter what kind of function it is. If it's trapped in there with the x, it's a horizontal move, and it does the opposite of what you would expect, so x minus 2 will actually go to the right 2. If you add positive 5 to the end, how is it going to change? Same thing. We've talked about it before. It always does the same. If it's at the end, it's vertical. Positive 5 means it's going to go up 5. Don't worry about that one. And don't worry about that one. And don't worry about that one. Okay, that was a review for rationals. Come see me during speed if you're confused about anything.